the complexity and sophistication of the engineering in all the various disciplines that are brought to bear in lithography has reached the point that you really can't handle it by just kind of conventional good engineering practice. To really deal with all this interrelated complexity, the industry is kind of turning increasingly to computational lithography, where you really have to bring sophisticated computer science to bear on organizing the engineering and getting every piece of it to work together properly.
Yeah, and one reason for that, Alan, is that we are moving now deeper and deeper into the sub-wavelength lithography. I think one thing, what you referred to as the business as usual, that whenever we had the chip size or the half-pitch shrunk, we had somehow the wavelength of light to print it somehow kind of kept up with that. But from, say, 90 nanometer technology onwards, it's still going to be the 193 nanometer wavelength of light. So we are going from 90 nanometer, 65, 45, 32, maybe even 22 nanometer with the same wavelength of light. So it comes to be, as you just mentioned, the sheer explosion of the data, the volume of the data, and the computation required to do that is there is a tremendous growth, which is something we have not seen before, and possibly computational lithography is something which is an answer to these problems.
Because when you have all these disciplines needing to be organized together, there's a lot of potential for synergy there. And if you kind of consider the depth that each field in its own right has, fields like optics, device physics, computer science, tying all those together in an optimized way is a field with just tremendous scope. And I would say it's a very hot area for innovation, but it's also, because of the complexity involved, an area that's going to be fruitful for innovation for a long time to come. It's going to be a long time before organizing all those different fields together properly becomes mundane engineering.
Extremely important. I mean, for example, people who are physicists by training, they are quite often wearing the hats of a computer scientist. They're talking about algorithmic efficiency. And people who are computer scientists by training are also wearing hats of chemists, talking about resist developments and other methods. So somehow or other, all our expertise that's available within IBM are kind of dovetailing into this field called computational lithography. And it's really exciting to be in this field at this time.